Hello, welcome to my YouTube channel. In this playlist, we are talking about how to simulate Arduino boards using Proteus. But today, we are going to briefly see how we can measure the key bouncing using a DSO. We will also learn the setup of DSO to capture the key bouncing event. And at the same time, we will briefly discuss how we can measure the period of the key bouncing and how can we solve the issue of key bouncing using key debouncing technique by using a delay in our program. So let us start the video. You can see I have a power supply which is generating 5 volt DC, and I have connected that 5 volt DC to my breadboard. Here on the breadboard I have a switch and I have used a resistor of 10 kilo ohm which is connected following the pull down technique. So here we have the 5 volt DC and it is connected to the switch via a jumper, and then the other terminal of the switch is connected to ground using a 10 kilo ohm resistor which is connected in the pull down technique. So now let me just connect the probe of my DSO and show you the screen of my DSO. So here if I press the switch, you can see I can see 5 volt or 0, 5 volt or 0, but I am not able to capture the key bouncing event because that particular event is of very small period. So how can we capture the key bouncing using DSO? For that, remember, you will have to use a feature called triggering in your DSO. Here we have the triggering. I will go for the modes or the menu which is available with my DSO. Let me briefly discuss about the types of triggering we have in our DSO. So first of all, I am going to use edge type triggering. I'll be generating the trigger from the source 1, okay, because our signal is connected to source 1. I'll be using DC coupling for capturing the triggering event, and then I'm going to capture the triggering when the signal is going from low to high, or we can say rising edge of the signal. Now here in this button we can set up at what level or at what voltage level we want to capture the triggering event. For example, I am going to set up that the triggering will take place whenever my signal crosses 500 millivolt. Okay, so here I have set my triggering level, and at the same time I will set up that the triggering will be a normal trigger. So this is all about the setup, and now you can see on my screen the signal is stopped. So now the question is, whenever I press the switch, the triggering event will take place and my DSO will capture the triggering event. Let me press the switch and you can see, let me zoom that part, and you can see this is the event when my switch moves from 0 to 5 volt. But whenever the switch is moving from 0 to 5 volt, we can see that the transition is taking place with a small event or a ringing event. We call this ringing of signal, and this is due to the key bouncing. Let me press the switch again. So you can see this particular ringing is not necessarily the same. It actually changes every time whenever I makes the key pressed. So every time whenever I presses the switch, this particular ringing event will change or key bouncing may change. So this is the behavior for a normal switch. Let me change the switch and show you that this behavior may change from switch to switch. Okay, so for that, what I am going to do is I am going to connect another switch again using the pull down technique. Okay, so I am connecting the second switch to my breadboard, and you can see now I have connected my second switch. Here this switch is connected to VCC. Okay, and then the second terminal of the switch is connected to a resistance which is going to ground. This resistance is of 10 kilo ohm. Now let us see if this switch also generates a similar behavior which was generated by the previous switch. Let me briefly press the switch. Okay, now you see here the behavior of this second switch is totally different from the switch which was used in the first case, and you can see that the key bouncing is taking in a very different manner and the switch is behaving totally differently from the previous switch. Now the question is, how can you measure the time period for key bouncing? For that you can use the cursor and move the cursor to check when the signal is getting settled. So let me show you here. It is taking somewhere around 310 nanoseconds to settle the switch. Now let me again press the switch, because every time whenever we press the switch, our signal may take different time period to settle down. So here, now you see here, the switch is settling at a very small time period. So the maximum time taken by the switch to settle, you have to note that, and that delay you have to introduce in your program to overcome the issues related to key bouncing. In this way, you can measure the delay, and then correspondingly you can introduce the same delay in your code to overcome the issues related to key bouncing. If you have any queries related to this video, please post them in my YouTube channel. I will be replying that. If you have not subscribed my channel, then I would request you to please subscribe my channel. Thank you.